morning, we are the Escalante RoboRaiders, and we would like to thank you for judging our Lego League competition.
Our project task was to identify and potentially solve a human physical or social problem faced during long-duration space exploration within our solar system. Today I am sure you will hear and see many excellent presentations from other LEGO teams about problems faced in space, such as the production of food, water, and oxygen, staying fit, recycling waste, and improving the spacesuit, among others.
We believe the biggest problem with long-duration spaceflight is the long-duration part. Many problems can build up, such as exposure to deadly cosmic radiation, bone and muscle loss, nutritional deficits. There's a lot of stress, which leads to decline in mood, depression, and sleep deprivation. Imagine all of us living in a room this size, maybe half this size, for 8 months. NASA has done tests like these, and the results are not good.
But someday and someday soon, we are going to be sending people to Mars. It'll be awesome.
Okay, so why will it be awesome? Because of that box right there. What if I told you, in that box, we could reduce the travel time to Mars from 8 months to 40 days?
What if I told you that in that small package we could reach the moons of Jupiter in a year, or the rings of Saturn in 2?
How much would you pay for something like this? 100 million? 10 million? Sure. A million?
Come on, we're talking NASA's budget.
But don't answer yet, because this one's on xenon, which is relatively cheap, and solar energy, which is free, of course. May I present to you the ion propulsion engine?
Ion propulsion engines are 10 times more efficient than the normal chemical rocket and can reach final speeds of around 200,000 miles per hour. The space shuttle reached a top speed of around 18,000 miles per hour, and the Saturn V, the most powerful chemical rocket ever launched into space, traveled at 25,000 miles per hour. Sound like science fiction? Hardly. A simple version of the ion propulsion engine has already been used in a few NASA missions.
Well, how is it better than the other two chemical rockets? It is very efficient, with fuel efficiency approaching 90%, can accelerate almost indefinitely, and can reach much higher final velocities than the chemical rockets. The chemical rockets, on the other hand, are almost 30% efficient, which is incredibly inefficient. 4/5 of the total weight of the rocket is fuel, which is very heavy, and they must carry their own oxidizer to work both in space and on Earth, increasing the weight. You may be wondering, how does ion propulsion work? Well, it works by accelerating ions and then sending them out of the back of the engine. So they put up some xenon, and then they hit it with electrons, which makes it negatively charged. And so since opposites attract, there's positive grids on the other side, and the negative xenon atoms go to the positive grids. And then when they hit the positive grids, they become neutrally charged and exit the rocket at speeds of 30 kilometers per second. So we have some improvements. First, using a better fuel. Normal propulsion engines use xenon, but we use radon, which is twice as efficient because it has a lower ionization energy and a higher atomic mass. Second, we would like to use graphene instead of xenon. Graphene instead of aluminum, because graphene is 1/227th the weight of aluminum, and it is 200 times stronger than steel because it is made of two.
Now we have all seen the future of spaceflight, the ion propulsion engine. With our improvements, we believe that this little engine will propel space travelers further and faster than chemical rockets ever could.
Faster travel equals safer travel. Less time to break down mentally, physically, and socially. And less time will also reduce the amount of time astronauts are exposed to deadly cosmic radiation and reduce the amount of supplies astronauts will need to carry. The ion propulsion engine, top speed of a Lamborghini, fuel efficiency of a Prius, an acceleration of a potted plant.
Now, would you like to take a closer look at our prototype?
Would we like to?
Sure.
Yeah, we'd love to.